Hello, ladies and gentlemen, and welcome to this UNISECO project presentation focusing on the Finnish case study. In this case, it's a transition towards carbon neutral milk in Finland. My name is David Huisman, and on behalf of the Natural Resources Institute Finland, also known as LUKE, we welcome you. The Finnish case study is based on the concept of carbon neutrality in dairy production with the use of biogas technology. We'll be focusing on the dairy-intensive region of Nivala, located in central Finland. The farm comprises of dairy cows and fields used to harvest silage and cereals for feeding the cows. Essentially, the main point of study is how to reduce the impacts of dairy farming without sacrificing the economic viability of the area. As we may know, in Finland, the agriculture industry, it's what drives the economy in the rural areas of the country, in areas with low population, with dispersed population. So this will basically be the dilemma of the study. However, the main sustainability issues revolve around the intensification of dairy farming. Farms become much bigger, but the number of farms are reduced. They go down, they decrease. And this is pushing small farms out of business and is increasing the environmental impact in the area. What will be the solution? So this will be bioproduct plants that produce both bioenergy and organic fertilizers. These are seen as the solution as they can offer valorization of nutrients, biofuels, and energy for the farms and the region. This transition is an ongoing transition, which means that in Finland, agro-environmental measures are widely adopted on farms already. However, the biogas production is limited and modest compared to other European countries. UNISECO is a project that focuses on the enhancement of the sustainability in farming systems with the implementation of agro-ecological practices. For this to happen, a theoretical real-life example was taken into consideration, which involved two main actors, Valio, which is the biggest dairy cooperative and milk processor in Finland, and the town of Nivala, with the installation of a centralized biogas plant that will be fed by several farms in the area. The two main agroecological practices identified in this case study with the installation of a biogas plant are biofertilizer production and biofuel production from cow manure and grass silage, which is the main biowaste. Biofertilizer production is taking place in a secondary treatment plant. The digestate is the product, the solid product that is left over from the anaerobic digestive process once the biogas have been removed. This digestate is rich in nutrients and can be further separated to obtain biofertilizers with high concentrations of nutrients such as nitrogen, phosphorus, and potassium. This is known as nutrient valorization, where the biowaste nutrients obtain high value in the market. The second agroecological practice, which is biofuel production, is obtained directly from the biogas in the anaerobic process. This biogas, which is not totally pure, it contains CO2 and other gases, is purified. The purification plant obtains biomethane of 99% purity. This biomethane can be further treated and transformed into biofuel. Biomethane in a compressed form for smaller vehicles and general use, and liquefied biomethane, which is also known as bio-LNG. This liquefied portion and variant of biomethane is suitable for heavy machinery and heavy vehicles, so it has high market value. There's a series of sustainability implications and trade-offs within the practices. In the case of biofertilizers, the main idea behind the practice is to substitute commercial mineral fertilizers that are currently used by the farms for the production of silage and other crops. This practice has the potential to reduce the adverse effects of fertilizer runoff in water bodies that lead to eutrophication, reduce the carbon footprint from mineral fertilizer acquisition, and improve the farmer's control on nutrient circulation. On the other hand, it can increase emissions and cost of transport due to the transport of the different biowaste and in the several farms to the centralized biogas plant. Furthermore, it can reduce the organic carbon in the soils of the dairy farms, as we'll be introducing high concentrated fertilizer. Biofuels would substitute fossil fuel usage both in farms and by the private drivers in the vicinity through the installation of a biomethane refueling station. The main benefits of biofuels derive from carbon footprint reduction, based on the previously explained fossil fuel substitution, and the improved nutrient circulation brought by the anaerobic digestion system. To be used on farms, however, machinery such as tractors and trucks will need to be upgraded to be able to use liquefied biomethane. This can raise the farm capital costs. Biofuels from biogas could thus reduce the dependency of farms on external sources of energy, and this way protect them from supply or price shocks that can result, for example, from global climate change or from various mitigation and adaptation efforts. So what is preventing Finland from adopting biogas technology? According to our study, is the low return to investment. As the return to investment from valorization requires increasing in the scale of the plant to such a degree that it needs feedstock from many farms, the transaction costs of managing the feedstock supply increase. So the economic risk in the investment is high compared to the expected profits, which leads to investment not taking place. The biofuel market, too, is uncertain. While biogas demand and traffic use is expected to increase tenfold by 2035, the competition with the electric vehicles is too big. It casts a serious question over the compressed biomethane market in the future. In the bigger picture, both the biofertilizer and biofuel markets are very dependent on policies guiding agriculture and energy sectors in the country. This brings considerable investment risk in an uncertain policy landscape. While it is difficult to assess the importance of local resistance in the withdrawal of value from the original plan, which was a concept that received a positive investment subsidy decision in 2018, it may be possible that complaints from some of the town residents could have posed a risk in tarnishing the value's milk brand, which far exceeds the additional revenues that the investment in biogas business will bring in the current business environment. The Finnish government, to some extent, has identified those barriers and there are key actions and instruments in place to try to address those barriers. The strategy adopted in Finland is to subsidize the investment costs of the biogas plants, include biogas on the list of fuels that can be used to fulfill the obligation of minimum required biogas component for fuel use in traffic, subsidize the valorization of the digestates and the infrastructure for distributing biogas within the transport section. Finally, is a strategy to promote biogas use in the advisory services and research. The stakeholders participating in the online workshop arranged by the UNISECO project in Finland were mainly satisfied with the measures set in the government biogas program of 2020. An interesting thing to note from this project and the results of the analysis is that policy changes supporting small-scale biogas plants that do not use valorization were given the highest priority. The results can also be interpreted as a signal of changing priorities on the type and scale of biogas concept that is more likely to be implemented in practice in Nivala, those based on biofuels and less emphasis on biofertilizers. This outcome reflects the participant composition of the stakeholders that were present. including representatives from that business segment besides the local actors from Nivala. This could indicate that due to the low return investment in valorization, as previously mentioned, the strategy is reoriented to build several small-scale plants on farms instead of a more centralized solution that combines manure and grass silage from several farms in the area. There are several key lessons learned in the Finnish case study of the UNISECO project. They're mainly based around the bias that emerging technologies face in already established markets. In this case, the valorization of diastates, or biofertilizer production, enters a market already defined by traditional policies for both biogas and nutrient management. So it must compete for funding and feedstock with biogas plant concepts that are already proven, such as biofuel production. This makes it very difficult to gain traction, and the new technology must demonstrate its benefits in order to enter the market. It was, in our experience, very difficult to demonstrate. This leads to situations where the emerging technologies that don't have as solid evidence as the most conventional options, they can be overlooked. The co-construction process itself can lead to new barriers for emerging technologies. However, overall, in the Finnish case study of Nivala, it is rather obvious that the existing policies on national and EU level are the key drivers of the transition. So this concludes our presentation. On behalf of Natural Resources Institute Finland and the whole team at UNISECO, I would like to thank everybody attending and everybody involved. If you have further questions, you can send them to the email shown in screen, to the project manager, Janne Helin, or to myself, David Heisman. Thank you very much, and I wish you a nice day.